So now let's discuss about separation techniques. So in the previous section we have discussed about what are the matter, three types of matter, element, compound, mixtures, how mixture is formed, homogeneous, heterogeneous. Now in this section we are going to talk about how we are going to separate these mixtures. So first let's begin with filtration. A very basic separation technique, and this is used to separate an undissolved solids in the water, right? So we can say that it is used to separate an undissolved. When we say undissolved, means they are insoluble solids from a mixture of solids and liquid, or you can say solution using filter paper. Right? So there are so many solutions which are used to separate the component using filtration process, like example sand and water, or collecting crystals, after crystallization, right? So let's see what are the steps involved in the process of filtration, right? So let's see the steps. So first is you have to place a filter paper in a funnel, right? And this should be above a clean beaker. Second step, you have to pour the mixture into the funnel. Then the liquid, means filtrate. What will happen to this filtrate? They will pass through the pore, right? Pores of the filter paper. You can say passes through the filter paper, and you will find that those substances which are soluble, they will go along with the water, and the residue or anything which is solid remains on the paper, right? And this works because particles are of different size, so they are getting held up in the filter paper, right? So you can say this works because solid particles are too large to pass through the pore in the filter paper. Let me show you a very basic diagram of the filtration. So you can see this is a very basic filtration technique. Right. So this is the funnel. Funnel is placed here. Then this is second step. In the third step, what is happening? It is being poured. In the fourth step, you can see these are the solid particles. And this is the fifth step, where you can see the separation is going according to the size. So it's very simple and very basic process, and easy to separate all kind of solid substances. But there are something which you have to take a note. Let me write the few note point. So first is vacuum filtration can be used for fine solid that clog filter paper under gravity. Under gravity filtration. Now, what are the other separation techniques where we are separating solid? So centrifugation can also be used, right? So we can say centrifugation can also be used separate solid liquid mixture, right? Especially when particles are too small or dense for standard filtration, right? Sometimes we also call filtration as solvation, right? Very important point. You should remember filtration is often used after solvation, when you have mixed something to remove undissolved solids. Right? Okay, so in this way we can filtrate anything, whatever we want, but it must be a solid or liquid solution. Next separation technique is crystallization. Right, so crystallization is used to separate again dissolved solids which is already dissolved. Undissolved you can remove through filtration, but let's say something is dissolved, now you have to extract it. So how to extract? You can say it is used to separate a dissolved solids from a solution when the solid is more soluble in, let's say, hot solvent than cold. Example where we can use this, so like copper sulfate crystals, from solution, right? Very simple steps are there for crystallization. So what are the steps here? Let's see the steps. First step, you have to heat the sample or heat the solution. Heat the solution gently to evaporate some solvents. Next, what you have to do? Now you have to allow the solution to get cool. Allow the solution to cool until saturated. Now next, what? Test saturation by using a cold glass rod, right? Then you have to leave the solution. So leave the saturated solution to slowly cool down. Cool down slowly. Next step, now you will see the crystals have formed. So you can say crystals will form as the solubility decreases. Now you can filter it, or you can say filter to collect the crystals. And rest you can wash it, so you can say wash the crystal with distilled water and dry on filter paper. After all these steps, you will be able to see the overall crystals. So before, let me show you how the crystals look like. Okay, there are so many steps involved here, so I want you all to see. Let me bring it down so that we can see our images together. Yeah, now this is fine. So this is the image. So what we are seeing here, in the first step, there is a hot solution, right? Just put it, then it's heated up, then it is slowly cooled down, and at the end they are filtered. Filtration is again a very important step here, because at the end we must collect the crystals, right? Okay, there are some important points we must know. Let me write the note point. The note is you should not boil to dryness. Some water must be there. You can say do not boil to dryness. Second, cool slowly. It's a very slow process. Next separation technique is recrystallization. Right. This is the diagram. You can stop and you can see the image. Right. Before, let's begin with the recrystallization process. Recrystallization is used purely an impure solid by dissolving in a hot solvent. Where we use it, you can say it is used purify an impure solid by dissolving it in hot solvent, right? And allowing it to crystallize. When they will get crystallized? As the solution cools. Right? Where we use this method, what examples where we are using recrystallization? Purifying benzoic acid, or removing solid and soluble impurities. From a sample. Let me show you an image where how we can use this recrystallization method. Let me show you one more time. Yeah. So in the recrystallization method, let me bring it up. Yeah. What we can see here, let me write the steps and we'll see how we can separate. So steps are also very clear here. Step first, add a minimum amount of hot solvent to the impure solid until it dissolves, right? So this is the first step. I'm putting number. Now next, if solid impurity remains, perform hot filtration to remove them, right? So next, third step, you have to slowly cool down. Allow the solution to cool slowly at room temperature, right? This is second step, this is the third step, right? Now what you will find, you find the crystals are formed. So crystals of purified product will begin to form as solubility decreases. Now you have to collect the crystals. Very easy method, by filtration you can separate it. Now you can wash the crystal with fresh water. Why? To remove further soluble impurities. To remove soluble impurities. And then you can dry it on filter paper or dry on any other dry stuff. Dry the crystal and you will get the crystals. So recrystallization is again a very good, powerful separation technique, right? There are some note point we must remember during the process. What are the note point? Let me write it here. First note point is always use the minimum amount of solvent to avoid loss of product, right? If you're taking more water, then might be it will get more dissolved and you will get something else, or it will delay the process. Cooling the solution slowly help from larger purer crystal, right? Use Bichner filtration. Why? To reduce the pressure due to gravity. Under reduced pressure is faster and remove more effectively, right, than gravity filtration. So we should not keep the solution and wait, right? So this method separates based on differential solubility, right? We can use this method. Next method is simple distillation. This is the fourth one. Simple distillation. We all know this, how simple distillation works. Let me show you an image of simple distillation. So simple distillation method is where the separation is based on difference in the boiling point. Let's say you have taken more than two substances and both substances have a different boiling point, and you want to separate both the substance from the solution. So the best idea is using simple distillation. So you can say simple distillation is used separate a solvent from a solute or a pure liquid from mixture based on difference in boiling point. So here the principle of separation based on the boiling point. Example, what are solutions you can separate? Separating water from the salt solution. Right? Or recovering anything. Steps are very simple. I will show you from the diagram also. First step is heat the solution. In round bottom flask. Right. Next step, liquid with a lower boiling point will start evaporating first because of the less boiling point. Liquid with the lowest boiling point evaporates faster. I mean first, right? And of course faster based on the temperature. Now what will happen? The vapor passes through a condenser. This is called condenser. This one. We can say vapor passes into a condenser where it cools and condenses, right? So as they're getting cooled, that is distillate, the distillate is collected. When we say distillate, the meaning is purified liquid. Is collected in a clean beaker. And other components will be remain back in the solution. So you can say that the solute are left behind in the flask. Right? So simple method In the same way, we have fractional distillation. Let's talk about next separation technique. Fractional distillation. Fractional distillation, when we have lots of many things are there. Let me show you one diagram. So in the fractional distillation, you can see there are many things is being removed from a column called fractionating column, and this particular method is used to separate your petrol, diesel, kerosene oil, naphtha, lubricating oils, right? Now, what is fractional distillation? Similar to simple distillation, but here we are separating many things, many miscible liquids. So you can say that fractional distillation is used to separate two or more miscible liquids with similar boiling point, right? So you can see in this fractionating column there are so many things mixed into this crude oil. Let's say petrol, naphtha, kerosene, diesel, all have a different boiling points. So the different temperatures are given, and based on the temperature, based on the boiling point, the substance starts evaporating, and things are getting separated, right? So example where we use this components of the crude oil. What are the steps involved in this process? Steps are, again, as this is an industrial separation technique, crude oil. So first you have to heat the mixture. So you can say heat the mixture in a round bottomed flask. Next step, the liquid with lowest boiling point evaporate first, right? Because they have the least vapor pressure up, it will go up into the column and it will get separated, right? So you can see here refinery gas is 20 degree, that's the boiling point, so they will get separated. So you can say vapor passes up the fractionating column. This is the fractionating tower or column, you can say, allowing better separation, right? Then vapor will be condensed. So vapor enters the condenser. Of course, here also we have to separate condenser to cool and condense the liquid. The distillate is collected in a beaker. Later on you can separate it. the distillate is collected. In a beaker. In this way, you can again increase the temperature and the process of separating the other things keep on going. So this is how we can do fractional distillation, right? There are some important points we must know. What are the note points? For, let's say, if you are extracting or removing for ethanol and water, for ethanol which ethanol and water, right? So ethanol has 78 degrees Celsius boiling point, water have 100-degree boiling point. So water heat to 78 degrees Celsius first. Why? To distill the ethanol. And then later on, no need to put it into 100 because already you have removed. Use an electric heater, best way. When you have a flammable liquid are present, right? Crude oil, separated by fractional distillation, I have shown in the diagram. Right? Right? So these are some important points we must know. Next separation technique is paper chromatography, very basic one, and